Let's clear all these questions in aldol and cannizaro reaction. The first one, why dilute base is used in aldol condensation? What is self or cross reactions in both aldol and cannizaro reaction? And order of cannizaro reaction at different basic mediums. And why cannizaro reaction is disproportionation reaction? Why no alpha hydrogen carbonyl compound prefer to make cannizaro reaction? Let's clear all these doubts in this video. Watch complete.
Let's start. Two important named reactions from carbonyl compounds. The first one, aldol condensation. Let's see the conditions for aldol condensation. Carbonyl compounds should have alpha hydrogens and dilute base are used in this reaction, like dilute NaOH or BaOH twice. What is alpha hydrogen? Aldehyde or keto are the functional groups. The beside carbon is called alpha carbon. The hydrogens of beside carbon or alpha carbon is called alpha hydrogens. To make this reaction compulsory, aldehyde or ketone should have alpha hydrogens. Here there will be types of aldol condensations, that is about inter and intra. Inter means between two carbonyl compounds, intra means within the same carbonyl compound. Under inter again some cases. Case 1, here two carbonyl compounds involved in the reaction. Let's take A and B. Suppose A and B both are having alpha hydrogens. Both are having alpha hydrogens. Two products are possible to form here. Two are self, which means in both steps two reactants only involved, like same reactant involved in two steps of the reaction, either 2A or with 2B. Similarly, two cross reactions also possible. In first step A is involved and second step B is involved. This is one possibility. Same way, one more cross product. In first step B is involved, second step A is involved. So two cross products means this is one combination, this is another combination. So total here 2, here also 2. Together how many products possible? If both are having alpha hydrogens, total 4. 2 self, 2 cross. That's how it will be. Coming to this 2, where only one of the carbonyl compound have alpha hydrogen. So A is having alpha hydrogen, B doesn't have. Then two products are possible. One is self, where in two steps A only involves. One cross is possible. First step A involves because it has alpha hydrogens. Second step B get involves. So one self, one cross is possible. Case 3, if no alpha hydrogen is present in both of the carbonyl compounds, then no reaction there. If no alpha hydrogens, then no aldol, means which reaction takes place? Cannizaro reaction is possible. These are the conditions or cases based on the alpha hydrogens in this. Now we are going to discuss mechanism of the aldol reaction and what exactly aldol reaction will discuss. Let's start. What is the aldol reaction? Let's take acetaldehyde which have alpha hydrogen in presence of dilute base. Generally they give dilute OH minus or NaOH. Get this product alpha beta unsaturated carbonyl compound. Sorry. First we get beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound is the general name that over heating lose water, OH minus from this carbon, H plus from this carbon. That's how we get beta hydroxy carbonyl compound. CH3 CH double bond CH C double bond OH. So this is alpha, this is beta. So alpha beta hydroxy so here we get alpha beta unsaturated carbonyl compound. This is nothing but aldol reaction. Let's start mechanism for this reaction. So there will be two steps here. So carbonyl compound which contain alpha hydrogen involves in the reaction. So the dilute base take H plus ion from CH3. Why we are using dilute base? Why not concentrated base? Because carbonyl group is negative group. It pull electron towards this side so that this alpha carbon is acidic. So it easily lose H plus ion. So the OH minus ion accept H plus from alpha hydrogen and lose water and get enolate ion as the intermediate, which is CH2 minus and C double bond OH. This is the step 1, which is nothing but making enolate ion. This enolate ion involves in second step with other same reactant, because here we took only same reactant. So this is other mole, and whatever is formed here that I am writing CH2 minus CHO. So this one will attach to this one when this bond shift over this. Then what is the result? CH3 CO minus H CH2 C double bond OH. So whatever the H2O released in first step provide H plus, that will attach to O minus and becomes what? OH group. This is nothing but what we got in this step. So that is beta hydroxy carbonyl compound. So beta hydroxy carbonyl compound. This beta hydroxy carbonyl compound overheating lose H2O. How it lose H2O? This carbon is beside of negative group, that is this alpha carbon is beside of CHO, so that it is more acidic. This lose H plus ion and this bond will shift over this, so that this OH minus will go out as OH minus. Then what is the result? CH3 CH double bond CH C double bond OH. That's how alpha beta unsaturated carbonyl compound is going to form. This is case 1. Case 2 is where one of the carbonyl compound have alpha hydrogen. Suppose if you take CH3 C double bond OH plus HCHO. So here this one have alpha hydrogen, this doesn't have alpha carbon itself. So where alpha hydrogens are present, where no alpha hydrogens are present, then in this case the product is, in first step always the carbonyl compound which have alpha hydrogen involves and get this product CH2 CH CHO, you can write C double bond OH, and this one is CH2OH. This is called as alpha beta hydroxy carbonyl compound. That is overheating, lose water and get alpha beta unsaturated carbonyl compound. Carbonyl compound. So this is how the cross product is possible. Self product means same like above, because in 2 steps same reactant only involves, means acetaldehyde only involves in 2 steps and get one self product. So if you want mechanism for this, so you can write in step 1 what reactant involves, same CH3CHO, because the carbonyl compound which have alpha hydrogen should involve, so that loss of water and get CH2 minus C double bond OH. In step 2 that will attacks to the carbonyl compound which doesn't have alpha hydrogens. So HC double bond OH is formaldehyde where no alpha hydrogen is present. So the enolate ion will attach to this one and get CH2OH and CH2 C double bond OH. That is how overheating lose water and get CH2OH. So what you will get is just CH2 double bond CH C double bond OH, which is nothing but alpha beta unsaturated carbonyl compound. This is how the reaction happens. Now coming to intramolecular aldol condensation. So intramolecular means the reaction happens within the molecule. So intramolecular means the reaction happens in the same molecule where 2 carbonyl groups are present in it. So one of the carbonyl alpha hydrogen lost it, this one lose with OH minus and get enolate ion. So this is the enolate ion what we get. That enolate ion attacks to this carbonyl group as like this. So the reaction will be like this. 6-membered ring. Let us take, this is 1, 2, 3, 4, 5, 6, 7. So second carbon, let us take this one. This is connecting to first carbon which is CHO, and this will be 6th carbon. This becomes OH group. That's how the reaction happens. 1, 2 and 6. So this one, next step what happens is lose water from this carbon, means second and 6th carbon, which is nothing but alpha, and this is called as beta. So alpha beta unsaturated carbonyl group is formed. So this is called a beta hydroxy carbonyl group or compound. This is called as alpha beta unsaturated carbonyl compound. So these are the products over intramolecular aldol condensation. So coming to cannizaro reaction. This is the next most important reaction. So where no alpha hydrogen is present, that undergo this reaction, and concentrated base is used here. Let's start the reaction. Carbonyl compound which doesn't have alpha hydrogen, generally formaldehyde or benzaldehyde will take. So in presence of concentrated NaOH or 50% NaOH, what happens is this reaction takes place. So HC double bond O minus Na plus, that is salt of carboxylic acid, and also alcohol. So here you will take 2 moles. Same reactant undergoing oxidation, because aldehydes to acid means oxidation, gain of oxygens, and the same way aldehydes to alcohols is reduction process. So same reactant undergoing oxidation and reduction, so it is called as disproportionation reaction. Mechanism we can write for this. Mechanism will be, here also you can make 2 steps. HC double bond OH, when it react with OH minus, nucleophilic addition happens here. Then what is the result? HO minus HOH will be formed. This is step 1. Depends on the strength of OH group, the respective compound is formed. This is with strong base. This is step 1. Now we can write step 2. So whatever is formed in the starting, that will make the reaction. In presence of this O minus will come back and hydride shift occur in this reaction. So this H minus will go and attack here, because just to neutralize carbon bonds, the H minus will go and attacks to the carbonyl group. Then what is the result? We get HC double bond OH and also HCO minus H and then H. So this is acid, more affinity with the sodium, so it will give Na plus O minus, that H plus will attack to this oxygen. Then the resultant products are HCOONA and the other one is CH3OH. That's how alcohol and salt of acid is going to form. This is nothing but cannizaro reaction, and example is disproportionation reaction. So here rate equals to K into, for aldehyde, power 1 and OH minus power 1. If it is very strong base, then here in this case the intermediate is O minus CHH will be the product, as like this. Intermediate, when we take concentration of base power 1, suppose if you take base is double concentration like OH minus power 2, then the intermediate is O minus H and here also O minus, like more proton lost because concentration of base is more. So here the order is second order because powers we have to add, and here is third order. Those are important points related to this. Let's see intramolecular intramolecular cannizaro reaction. So here C double bond OH, C double bond OH. In both the cases no alpha hydrogens are present. Then one of the carbonyl group is become COO minus Na plus and the other one is CH2OH. Same way this is intramolecular. If you take inter cannizaro reaction, let us take two different reactants having no alpha hydrogen. So here nitrobenzaldehyde, here methyl benzaldehyde. If these two react in presence of concentrated NaOH, then the one which have electronegative groups easily undergo oxidation and becomes acid. So NO2, COO, Na, and along with this we get CH3 CH2OH because CH3 group is electron donating group or plus I group or hyperconjugative group, so that here alcohol is formed, here acid is formed. That's nothing but intermolecular cannizaro reaction. This is nothing but intramolecular cannizaro reaction. Hope it is clear. Thank you. Please like and subscribe.